Hello, in this demonstration we're going to show the execution of a small code using the LEDEL library executed over a RISC-V system. First, we can see that in this machine we already have imported the RISC-V demonstration Docker image, as we can see here. So now we are going to instantiate a container offset image with this command. We can check that the container has been created successfully with the command docker ps. As we can see here, the container has been created using the image RISC-V LEDEL demonstration. So now we're going to execute the docker exec command, which we need to pass the name of the container created, and this command will open a console to the inside of said container. Here we can see that now the console is inside the container, which is an emulated Debian system. This is because the emulated RISC-V system will be run over this Debian system. Inside the Docker, we have already installed the LEDEL library, so if we head to this folder, we can find here an example code of a training network, a training sample for the MNIST dataset using the LEDEL library. Here is the code where it downloads the dataset, builds the network, executes the training, and then save the training network to an ONNX file. Also, the train weights are downloaded, are separated in another file. In this Docker container, this code has already been compiled, but for the sake of this demonstration, I'm gonna remove the compilation folder, and I'm going to show the whole process. I create the same folder again and execute the CMake command, which starts the compilation of the code. Then with the command make, we generate the executable file. As we can see here, this is the executable file, and if we execute it, the code I just saw will start. First, it downloads the MNIST dataset. Here we can see the network we are using for the training, and the training starts. Normally we will use more than one epoch, but for the sake of the demonstration, we are gonna just train with one epoch. And once this epoch ends, the result network, the train network, will be saved to a ONNX file. Here, now that it's finished, we can see that the network has been exported to an ONNX file. Before we start the RISC-V emulation, where we check if the network has been exported successfully, we need to transfer this ONNX file to the host machine where the Docker container is hosted. There, and now we head to the folder start RISC-V. Here there is a script that automatically will run the RISC-V emulation. I log into the RISC-V emulated system. And now we are in a RISC-V architecture emulated system. Here I can head to this folder, where now we have an example of LEDEL code where the inference of a network imported from a ONNS file is performed. Here is the line that imports the ONNS file. This initiates the inference of the network, and so as the result. Sorry. Same as before, the Docker container already contains the code of this part already compiled, but for the sake of the demonstration, I'm going to remove the compilation folder. I'm going to create it again, and we're going to compile using the same commands as before, but this time it's going to be compiled in a RISC-V architecture. Now we generate the executable file. Here we can see that the executable file has been created, and then we import the ONNS file that we have previously saved to the host machine. Now that the executable file and the ONNS file are in the same folder, we can execute it, and the inference of the network will start. Again, first we download the MNIST dataset. Here we can see that the loaded network from the ONNS file is the same we have used during the training, and the evaluation of the network starts. We can see here that the metric that is being achieved during the test corresponds to a trained network. It's not one belonging to a randomly initialized network, because the weights of the trained network has been successfully exported in the ONNS file. With this ends the inference of the network, and we can see that the final metric achieved belongs to a trained network successfully exported over the ONNS file. And with this, this demonstration ends.